Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 11.1, which is going to do with dilations. Now, section 11.1 is our first lesson for Geometry A, and it's going to get us off and rolling for this trimester. Now, dilations is something that we hinted back at in Geometry A when we talked about transformations. But we just talked about translations, rotations, and reflections. Now we're going to come back and take a look at what a dilation is and how we figure out if it is or not. So we have two learning goals for today. Our first learning goal is that you will be able to determine if a shape has been dilated or not. And then you will also be able to determine the scale factor of a dilation. So we're going to talk about what a dilation is, how we can determine if it is or not, and then figure out this idea of the scale factor if it is a dilation. So first thing up is a dilation. So a dilation is a transformation that can change the size of a polygon but leaves the shape unchanged, meaning that we can make the shape bigger or smaller, but in essence it maintains that same shape. So a 30, 60, 90 triangle would still be a 30, 60, 90 triangle. It just might be bigger or smaller. Now, a dilation has a center of dilation and a scale factor, which together determine the position and size of the image after the dilation. So I'll talk about what those two things mean in a bit and how we can figure them out. So let's kind of run through an example of a dilation, and then let's talk about this scale factor. So first thing is we have triangle ABC and its image triangle A prime, B prime, C prime after a dilation, and we're going to use these two triangles to answer the following questions below. So I'm going to go ahead and move this up. Alright, so the first thing they want us to do is to use a ruler to measure the following lengths. So they would have us go through and measure the length of AB, AC, and then BC, and then A prime, B prime, B prime, C prime, and then A prime, C prime. So they would have us go through and measure all three side lengths for both triangles. Now, I have already gone through and done that with our ruler, and then they also want us to go through and use a protractor to measure the angles. So you'd find the measure of angle A, B, C, A prime, B prime, C prime. So let's take a look at those real quick. When we go through and find all of those measurements, okay, I found AB, this length right here, to be 7 centimeters. I found AC to be 4.5, and then BC was 3.5. And then for our image triangle, A prime, B prime was 3.5. A prime, C prime is 2.25. And then B prime, C prime is 1.75. So I went through and found all of those measurements using a ruler, and we're going to use those measurements here in a second to help us understand what a dilation does. Now, the other thing was the protractor to measure the angles. So I found the measure of angle A, so this angle here, to be 22 degrees. I found the measure of angle B to be 33 degrees, and then the measure of angle C was 125 degrees. And then for the A prime, B prime, C prime triangle, found A prime to be 22 degrees, B prime to be 33 degrees, and C prime to be 125 degrees. So, before we get into looking at the side lengths, first thing I want you to note, okay, if you look at the angle measures for both of these triangles, measure of angle A and A prime are the same measure. They're both 22 degrees. B and B prime is 33 degrees, and then C and C prime are both 125. So this goes to point to part of the thing we talked about with the dilation, that it can change the size, but it leaves the shape unchanged. And part of that leaving the shape unchanged is that the angle measures stay the same. So dilations are going to preserve angle measure. So whenever you dilate a shape, angle measures have to stay the same. Now, what about side lengths? Because I said that it could make them bigger or smaller. It just has to keep the shape unchanged. So if we look at these two triangles, do these two triangles appear to have the same shape? Okay, they do. So what we also need to note is we have to deal with the side lengths. What do the side lengths tell us? So we're going to go through and complete the following ratios, and this is going to set up an idea with the side lengths. So what we're going to do is take the prime over the original. So if we take the length of A prime B prime, that's 3.5. And then that's going to go over the original, which is AB, so 7. And then we take A prime C prime, that was 2.25. And then for AC, it was 4.5. And then for B prime C prime over BC, prime over the original, so it's 1.75 over 3.5. So what we're going to do is we're going to take our calculator and we're going to take these ratios, these fractions, we're going to simplify them and see what we get as a result. So if we take our first one, which is this 3.5 over 7, so I do 3.5 over 7, then we are going to get, and I typed it in twice, 3.5 over 7, and we end up with this 0.5. So 0.5 also equates to 1/2. So this A prime B prime over AB simplifies down to 0.5 or 1/2. And then if we do the same thing for AC, so it's going to be 2.25 over 4.5, we end up with 0.5 again. So that's going to give us 1/2. And then if we do the same thing for BC, if we do 1.75 over 3.5, we end up with 1/2 again. So, what do we notice about with the side lengths? Whenever you dilate a shape, if it has been dilated correctly, okay, angle measures will stay the same, and then we're also going to notice that there's going to be a scale factor where it's the same ratio from the original to the prime or from the prime to the original. Okay, meaning that AB was reduced in half to get 3.5. AC was reduced in half to get 2.25, and BC was reduced in half to get 1.75. So a few things to determine whether or not something is a dilation. Angle measures have to stay the same, the shape has to stay the same, and we have to maintain this scale factor, meaning the ratio of the side lengths, prime over original, prime over original, prime over original, has to maintain the same number for all three side lengths. If one of those doesn't match up, let's say this one was 0.4, then this would not be a dilation. So that is our brief look at a dilation. So now we're going to go through and practice determining if something is a dilation or not, and then figuring out the scale factor in a coordinate plane. But before we get there, a few other things to indicate whether or not something is a dilation. So, we have this bit of information here that's going to kind of hint us to that. Now, the center of a dilation is a fixed point about which all points are transformed by a dilation. So that's going to be the point at which all measurements are dilated. Most of the time it's going to be the origin at 0, 0, but sometimes they will choose one of the vertex or some other point. Now the ratio of the lengths of corresponding sides in the image and the pre-image is called a scale factor. So that 0.5 or that 1/2 is our scale factor. It's that ratio of lengths that takes the image, the prime, over the original, the pre-image, the non-prime. So whenever you're trying to figure out scale factor, it's prime over original. And then you just have to simplify that fraction. Now, properties of dilations. Dilations have to preserve angle measure, which we found, so they have to have the same angle measure. Dilations preserve betweenness. They preserve collinearity. Dilations preserve orientation, so that means it has to face the same way. That means you cannot reflect it, that means you cannot rotate it. A dilation just maintains the same orientation. Dilations map a line segment to another line segment whose length is the product of the scale factor and the length of the pre-image, and dilations map a line not passing through the center of dilation to a parallel line, leave a line passing through the center unchanged. Main thing to know, to take away from all this, dilations preserve angle measure, betweenness, and orientation, and they have to maintain that same scale factor for all the sides. So, with that said, let's get into example 1 for today. Alright, example 1 is going to ask us to go through and determine if the transformation is a dilation. If so, provide the scale factor. So, does the transformation preserve angle measure, betweenness, collinearity, and orientation? So, if we look at A, so we have triangle ABC is this smaller triangle, and then A prime, B prime, C prime is this larger triangle overall. So, first of all, we need to determine if this is a dilation. So, just by looking at it, we can kind of determine some of this. Does it appear that we have the same angle measure? Does it look like it's the same shape, but it's just smaller or larger? Okay, I would say that it preserves the same angle measure. Betweenness means that it would maintain the same distance from this side length to this one the whole way, and then the same thing for BC and then AC. Doesn't mean that it has to be the same distance for all three sides, just the whole way through that shape or that side. Orientation, is this facing the same way? Okay, it is. And by looking at this, you can determine that this is a dilation. So this is a yes. So the next thing we need to do is figure out the scale factor. Now there's a couple of ways we can figure out the scale factor. The first way is you could use the distance formula. So that's that square root of x2 minus x1 squared plus y2 minus y1 squared. So you would choose a side length like AB and then A prime B prime. You have to go through and find the distance for AB and then A prime B prime. And then you would take that and you would set up a fraction. Now the other way we can do this is we can use a point on the coordinate plane. So if we look at C and C prime, okay, both of these reside on the y-axis. So that means that it's a 0, comma number for both of these points. Okay, C prime is at 4, and then C is at 2. Remember, we need to take the prime over the original. So we're going to set up a ratio of C prime over C, which means we have 4 over 2. And if we simplify 4 over 2, we would get a scale factor of 2. So my answer for this is that yes, it is a dilation, and my scale factor, because it is a dilation, is 2. Meaning we took this original triangle ABC and we doubled it. So we multiplied all the properties by 2. So that means instead of being at 1, 1, B is now at 2, 2. C is at 0, 2. So then it's now at 0, 4. And A being at negative 2, negative 2, we multiply that by 2, it ends up at negative 4, negative 4. So, wouldn't matter which one you would choose, you just have to choose a coordinate point, stick with either the x or y, set up prime over original, simplify, and then you have your scale factor. So that is what this answer means, that yes, it is a dilation, that this shape got bigger and it preserved everything it needed to, and that our scale factor was 2, meaning we multiplied this shape by 2 and it got bigger. So we doubled the size of the original triangle. Now, if we look at B, for part B, we had to first determine if this is a dilation. So if we look at B, we have A, B, C, D parallelogram, and then A prime, B prime, C prime, D prime. So, does it preserve angle measure? Okay, if we were to go through and measure the angles, it looks like it would maintain that. Betweenness, this doesn't really follow for that. And the main indication for why this is a no is because the orientation. Okay, shape faces 2 different ways for the original and the new. So that means that this is not going to be a dilation. And the reason it does not is orientation. Okay, this shape has not been dilated, yet it has been reflected. And that is our answer for part B. All right, for C, so let's go ahead and move this up here real quick. So for part C, we have triangle ABC and then A prime, B prime, C prime. Just by looking at this, would you say that this is a dilation? Okay, this is not a dilation, and the reason that it's going to be not a dilation, okay, 2 things. One, right away, orientation has changed. Okay, C used to be at the top point, now C is at the bottom. So this shape has been reflected over the line x equals negative 0.5. So it's been reflected. So orientation is one reason why. Another reason would be that the angle measures for A prime and C prime have changed. So you can either go with that the orientation has changed or that the angle measures have changed. And that is your answer for C. Now for part D, we have 2 pentagons. So we have A, B, C, D, E, and then A prime, B prime, C prime, D prime, E prime. So we have these 2 different pentagons. We have to determine if it is a dilation. The smaller one is our original, and then the larger one is going to be our prime, our new one. So, by looking at these 2, does it appear that a dilation occurred? Okay, it appears angle measure stayed the same, appears betweenness stays the same, and orientation also stays the same. angle measures appear to be the same measure. Betweenness is the same for the entire side length for all 5 sides, and then it faces the same way. So we're going to say yes, this is a dilation. Next, we have to determine scale factor. So to determine the scale factor, we can do this a couple different ways. The first way that we could go through and determine this is we just need to choose a point, okay, say A, B, C, D, or E. We take that point, and then we're going to go through and create a fraction. So I'm going to take B and B prime. Remember that we want it to be the prime over the original. So B prime resides at 3, because it's up 1, 2, 3. And then B is going to be at 2 because it's up 1, 2. So it's going to be 3 over 2. Cannot simplify 3 over 2. If we did, it would be 1.5. We're just going to leave this as a fraction as 3/2. And 3/2 is our scale factor. Meaning that they took this original pentagon and they multiplied it by 3/2, or they increased it by 1.5. So every point on this graph of this pentagon was multiplied by 1.5 to give us A prime, B prime, C prime, D prime, E prime. And you could check that by going through and multiplying all the other points. So E was at 1, negative 2, and now it's at 1.5, negative 3. And you could go through and check that for all the others, but that is our answer for part D. So when you're on the homework, first of all, just look at the 2 shapes they give you, determine in your mind whether or not it appears it is a dilation. The things to look for: does it preserve angle measure, the same shape, betweenness, and does it face the same way? So orientation, I mean, it has to face that same way. It cannot be reflected or rotated. Then you would say yes, and then all you have to do is choose a point, and then you go through and set up your scale factor. Prime over original. That's what you need to keep in mind. So whenever you figure out your scale factor, you take the prime and you put it over the original. New over old. Alright, so that is how you do example 1 on determining if something is a dilation and then finding the scale factor. I do want to real quick talk about example 2, where it talks about determining the center of a dilation and scale factor. And these are not going to be in the coordinate plane. So example 2, they're just going to give us 2 shapes that have been dilated, and they want us to figure out center of dilation and then scale factor. So to figure out the center of dilation, what you're going to do is take a ruler and you're going to draw lines going from the original through the prime, and you're going to continue it on. So we're going to go from C to C prime. And then we're going to go B to B prime. And then A to A prime. So you're going to draw a line from all the originals to their primes. And then where they all intersect, right there, that is going to be your center of dilation. So that's the point at which they were all dilated. Now, the next thing is they want you to figure out the scale factor, and how you would figure out the scale factor is that you would measure from A to this point, and then A prime to this point, which we will call P. So you would find the length of AP, and then A prime P. So you would go through and find the measure of those two lengths, and then again, you're going to set it up as the prime over the original. So you can set up a fraction and then simplify. For this case, for this problem, if I measure from A to P, we're going to get 6.5. And if we go from A prime to P, we're going to get 3.25. So from there, all we have to do is take the prime over the original. So it's 3.25 over 6.5. Just simplify that fraction, and we're going to end up with 0.5 or 1/2 as our scale factor. So if you are ever asked to find the center of dilation, again, you're going to draw lines going from the original through the prime and just continuing on. Prime, or original through the prime, original through the prime. Where they all connect is your center of dilation. And then to figure out scale factors, you just measure from the original to the center of dilation, and then prime to the center of dilation. Then just set up your fraction of prime over original, and then simplify. So, with that said, that is our lesson for section 11.1 on dilations, and our very first lesson for Geometry B. Main thing you're going to see on the homework is like example 1, where you have to go through and determine whether or not the shape is a dilation, and then figure out the scale factor. Okay, use a point on the coordinate plane to figure out that scale factor whenever it is a dilation. Real quick, if you're wondering if you don't have a point directly on the y-axis or the x-axis, like I've done for A and D, okay, if we took B and B prime here, just to show you real quick, if we did B prime over B, okay, it doesn't matter if you use x or y, let's use x. So B prime is over 2, and then B is over 1, so we'd have 2 over 1 or just 2. So it doesn't have to just reside on the x or y axis. To use a point, just choose a point, use either the x or the y value, set up your fraction, and then simplify. So, with that said, that is our lesson for today. Thank you guys for listening. If you have any questions, feel free to let me know the next time you see me or shoot me an email. I am more than happy to help however I can. Also, you can always take a look at my completed notes as a reference as you're working on the homework to help you guide you through that. So, with that said, that is all for today. If you need any help, just let me know, and I will talk to you guys later. Have a great day.